Okay, hi everyone. We're going to do fractions again today, but we're going to go into a little bit more detail on it. So we'll be doing similar kind of stuff, just going a bit more advanced. So we're going to start off with a starter question. So for this one, I'm going to put the question up on the screen. I want you to pause the video and have a go at doing it. So this is based on what we did yesterday. So I want you to put these fractions in order of size, starting with the smallest and going through to the biggest. So pause the video now and have a go at that, and I'll go through this in a second. Okay, so assuming that you've paused the video there, you should have had a go at putting these in order. So what we're going to do, we're going to go through which of these is the smallest to the biggest. So we'll put a line across there. So we said yesterday the denominator of the fraction, so the bottom of the fraction, that tells us how many parts we're splitting the whole into. So if we have a circle, for example, we're splitting it up into parts. So let's say this one here, the 1/12. What that means is we've split it into 12 parts and we've got one of those parts. So if you imagine we've split something into 12, that's going to be smaller than if we've split it into 8 or into 6 or into 5, because you've got more parts. So the smallest one is 1/12. Okay, going on to the next one. The next smallest, well, we can see that all of them have got one of each. So all we're looking for is which one have we split it into the most parts. So when the denominator is bigger, that's going to mean that the amount is smaller. So 1/8 would be the next smallest. Next one we've got 1/6, and the biggest one was 1/5. So that was what we were doing yesterday. We're going to go a little bit more advanced today now. So we did look at equivalent fractions. I'm just going to recap this as well, because we'll need this again today. So we've got a fraction here, 6/9, but this isn't in its simplest form. And the reason for that is because 6 and 9, we can divide them both by something. So think of a number that divides both 6 and 9. So think of a factor of 6 that's also a factor of 9. Okay, so if you got that, it would be 3. So we could divide the top and the bottom by 3. So that would give us 2 on the top, because 6 divided by 3 gives us 2, and 9 divided by 3, that gives us 3. So we've got 2/3 now, and sometimes if you do this you'll end up with one that you can simplify again. But this one, 2 and 3, they don't have any common factors. So that one is in its simplest form. So that one would be 2/3 as our final answer for that one. Okay, so now I want you to have a think about this one. Which is bigger out of 1/4 or 3/4? I'm sure some of you just know this straight away. But what I want you to do is have a think about what we're doing yesterday with numerators and denominators, and see if you can explain why it's bigger, the one that you think is bigger. If you're not sure, I'm about to explain. So if you want to have a think about it first, pause the video now, have a think about that. Okay, so 3/4 is bigger than 1/4. So I think we can kind of imagine that if we've got a diagram here. So this one, we've got 3/4. We've split it into 4, and we've got 1, 2, 3 of the quarters. This one is quarters as well. We've split it into 4, but we've only got 1/4. And we can see this one's smaller. If you had that much cake, you'd have a lot less cake than if you had the 3/4. So let's have a think about how else we can show it. So I'll just backtrack off a bit, I'll leave them there. So we've got 1/4. What that means is we've split it into 4 parts, and we've got one of those parts. Whereas 3/4, we've split it into 4 parts still, but now we have 3 of those parts. So when we've got the same denominator, so we've got 4 as the denominator and we've got 4 as the denominator, that means we've split it into the same number. So if you've got more parts, so 3 is bigger than 2, we've got more parts here. What that means is that we've got more parts, so we've got more with the 3/4 than we have with the 1/4. So this is going to be really important for what we're doing today. If you've got the same denominator, if the numerator is bigger, you've got more, it's bigger. And this is going to be question 1 on the sheet. So if you want to pause and have a go at question 1 now, you can do. If you'd rather watch the whole video first, then have a go at everything, that's fine as well. Right, so what we're going to do now, and this is the main skill for today, we're comparing the size of fractions. And this is going to be based on what we were doing with equivalent fractions yesterday. But the difference is we're not just simplifying. What we're trying to do is get it so that the denominator here of this fraction is the same as the denominator here. So what we saw with the previous example was that if we have the same denominator, if we've got a bigger numerator, so if the bottom of the fraction is the same, whichever one has the bigger top of the fraction, that's the bigger one. So with this one, they've got a different bottom of the fraction, they've got a different denominator. So we need to get them to be the same. So we need to try and use our equivalent fractions, so times in the top and the bottom of the fractions, to get it so that the denominator is the same. So look at this fraction here. What could we times the bottom of this fraction by to get it? So what could we times the 3 by to get it to be 6? So have a think about that. So what could we times 3 by to get 6? If we times it by 2, that would give us 6 on the denominator here. But it wouldn't be equivalent unless we also times the top of the fraction by 2. So when we do equivalent fractions, you've got to do the same with the top and the bottom. So we've also got to times the top of the fraction by 2. So we've got 4/6. And here we've got 5/6. So which is bigger than 4/6 or 5/6? The denominator is the same, so they're both split into 6 parts. So we can see that 5/6 is bigger. And I think I've got a diagram for this one. Yep. So we've got 5/6 here. And here we've split this, we've got 2/3. But we can see if we split that into 6, we've got 1, 2, 3, 4, 6. So we can see it with the diagram. But doing it mathematically like we did here, this is much better, because if you end up with some awkward fractions like sevenths or something, it's much easier to do it mathematically than it is to do it with a diagram. So make sure if you want to rewatch this section of the video, make sure you've got this, because this is really important. Right. So example 2, similar idea. We've got 9/12 or 5/6. So think back to the first example. What did we need to get to be the same so we could compare them? So we need to get the same denominator. So here we've got 12ths, here we've got 6ths. So we need to times them by something to get them to be the same. So let's focus on this fraction. What could we times 6 by to get 12? Because we want to get 12ths on both. So if we times this one by 2, that gives us 12. So we've got 12 on our denominator there. And we also need to times the top by 2, because otherwise we're going to end up with it not being equivalent. So we've got 10/12 here. So 10/12 is our answer to this one. 9/12 is our answer to this one. Which is bigger? Well, they're both split into 12, but 10/12, so we've got more of them. So our answer, 10/12 is bigger. So when you've got the same denominator, it's just a case of looking and seeing which is the bigger one. And what we're doing here really is we're looking for the lowest common multiple. We're looking to get what number is a multiple of 12 and of 6. And 12 works because that's a multiple of 12 and it's a multiple of 6. And we're going to see that even more importantly in example 3. So this one, this is going to be question 2 and 3 on the sheet. So this is a really important example. So this one looks a bit more daunting because we've got not just 2 fractions, but we've got 4 fractions. And we need to put them all in order of size. So what we're going to do first is exactly what we did when we had 2. We're going to try and get it so that we have the same denominator for all of them. So what we need to do is find the lowest common multiple of 12, 6, 3, and 4. So we need to work out, because they're our denominators, we want them all to be the same. So let's work out the lowest common multiple. So let's think, how do we do lowest common multiples? So we'll write out the multiples of 3. So we've got 3, 6, if I'll just put 3 at the top so you know that's what we're doing. 3, 6, 9, 12, 15. I'll stop there for now. We're going to do the multiples of 4. So we've got 4, 8, 12, 16, 20. So I'm just going to do the first few for now, and then we'll see why afterwards. So we've got 3's, so ticked off denominator 3 and 4. So now we've got to work out what are the multiples of 6, so we'll do that as well. So we've got 6, 12, 18, 24, 30. And so lastly, we've also got 12. We need the multiples of 12. So we've got 12, 24, 36. I'll stop there with that one. We don't need more than that. So what we want is to get all of the denominators to be the same. So we need a multiple that works for all of them. So what multiple is in the 3's column, the 4's column, the 6 column, and the 12 column? So see if you can spot a number that is in all of those columns. Okay, so 12 is a multiple of 3. It's also a multiple of 4, also a multiple of 6, and also a multiple of 12. So if we can get the denominator of all of these to be 12, we'll be able to compare them. So this one, double tick that, because that is already 12. We don't need to do anything with that fraction. That one's already in the form we want it. This one though, so the next fraction along, we've got a denominator of 6 at the moment, and we want a denominator of 12. So we need to times that by 2. And that will give us a denominator of 12. But to keep it equivalent, we need to do the same to the top and the bottom. So we need to times that by 2 as well, which gives us 10. So straight away, we've got that this one is 10 twelfths, and the first one we looked at, that's 6 twelfths. So we can see the second one is bigger. But to compare them all, we need to do all of them the same way. So looking at this next one, again we want a denominator of 12. What do we need to times 3 by to get 12? We need to times it by 4. So that gives us 12 on the denominator here. And we need to times that by 4 as well. That'll give us 8 twelfths. And lastly, we've got 3 quarters. So we need to times 4 by 3 to get the 12. And so we need to times the top by 3 as well. So that'll be 9 twelfths. So now let's have a look. So they're all twelfths now, so we can compare them. So the one that we've got least of, that's this one over here, 6 twelfths. So the smallest one is 6 twelfths. So then the next smallest one, that's here, 8 twelfths. Because this one's 9, this one's 10. So 8 twelfths is the next smallest. So we're going to write, so 8 twelfths is 2/3. So the next one along would be 2/3. The next smallest is 2/3. So next one along, 9 twelfths. So that is 3 quarters. And then the biggest one then is 5 sixths. So that one is questions 2 and question 3 on the sheet. If you finish both of those ones, there is question 4 as well, which is a bit harder. But if you get to the 50-minute time, you've not gone to question 4, don't worry too much. That is an extension one. We will be getting more practice with that later. So this one's a bit of a harder question because you've got more to do. But the method's still the same. You're still trying to get the same denominator so that you can compare them with the numerator. And just the last slide, this is the key steps. It's basically just a worded thing of what our steps are. So step 1 is we're going to use equivalent fractions to get the same denominator on both of the fractions. If you've got more fractions, you're just trying to get the same denominator on all of them. So if we use the lowest common multiple, that'll work, but you can get any number. As long as the denominator is the same on both, you'll be able to compare them. It's just that lowest common multiple, it means the numbers you're multiplying are not as big. And then after that, all you need to do is see which has got the biggest numerator. Whichever's the biggest, that's the biggest number. So at the top of the fraction, whichever one's bigger, that's the biggest number. And then this one's just explaining the last question again. If you've got more than 2 fractions, just get the denominators all to be the same, and then you can go from there. Brilliant. So good luck with the task. Let me know if you have any problems with it, and I will see you all tomorrow.